Hello, 11th graders. So we are moving on. We're gonna do a little bit more with trigonometry today, just talking about area of a triangle using your formula that we talked about in class a couple days ago. So we have a bunch of word problems here in front of us, and one thing I want you to keep in mind as we're moving forward, a few things that you should always be writing down before you start your problems. You should always be writing down all of your formulas. So that's the first thing. The second thing, you should always be drawing a diagram, especially with geometry material. So let's go ahead and try that out. A farmer owns a triangular plot, ABC, where the lengths are AB equals this, BC equals that, angle B equals that. Find the area of the plot. So I would first say we should draw the triangle. And it doesn't matter what your triangle looks like. It doesn't matter if the lengths that you draw are actually true to size, because I just want you to get an idea of the relationship of the side lengths to each other. So for instance, if I were to draw something like this and label this A, B, C. And it says that AB is 120, and that BC equals 240, and that angle B is equal to 130. Notice that BC looks to be shorter here, and AB looks to be longer here, when actually the reality is flipped. That 240 is larger than 120. But it doesn't really matter in this case, as long as you realize that the drawings that you draw will never be drawn to scale, ever. So this is really just to give us a general idea of what information we have and what they are in relation to each other. So when it says now to find the area, it might be a little bit easier to see that what you have are two side lengths and the angle in between, which you have a trig area formula, which uses that information to solve. And I'm going to write down that formula now. Remember that the idea is 1/2 AB sine of C, which means two side lengths and the angle in between. If I were to look at my labelings here, I am using A, I will be using A, but I'm actually using lowercase c here for my other side length. It doesn't matter. All I want you to know is the idea of the relationship. So I will be plugging this in for A and this in for B, or this in for A and then this in for B. It doesn't matter, as long as I make sure to use the angle in between them. I'm going to label what I do have. I have that A is equal to 240, B is equal to 120, C is equal to 130. And now I have everything planned out. I have a plan of action. I need to solve for this. Here are my ingredients. Here's my recipe. I can go ahead and go through and solve this. I'd like for you to plug this in and tell me what your answer is. So hopefully what you did is you plugged in 240, 120, and then sine of 130. The answer that you get should be 11031.0399809. It does say to the nearest integer, which means that you should round up to the nearest whole number. So we do 11031 because the number after it is a 0, which means I round down, which is really a misnomer, right? It should just mean round to the staying of that spot. Meters squared, because it's always good to include units. It's just safer that way. And there you go. You're done. All right, so sometimes information can be provided to you in different ways. Sometimes it says, hey, the area of the triangle is this, and it gives you information. And so I'm going to go ahead and draw just a random triangle. I just drew a random triangle. I didn't even think about it. I'm going to label it A, B, and C. I have no idea what measurements go there, but I've labeled it. And so now it says, hey, angle B is 25. I go in here and I label this as 25. Does that look like a 25-degree angle? No. But will I get a good idea of the relationship of the side lengths and the angles to each other? Yes. So it doesn't need to be perfect. If it stresses you out and you want it to be perfect, I could always go here and do, okay, well then this is B and this is A, and then that means that this guy is 25. You don't have to erase your stuff and change it, right? Just realize that you can switch it around if you want to, but the first place to start when you're drawing these triangle diagrams is just draw something that looks like a triangle and then start labeling the pieces. So B is 25, and then it says BC is 7. We want to find the length of AB. So I'm going to label AB as X. We want to find this length, and it gave us the area. So if it gives us the area, we should write out what the formula for the area is. Again, this is an idea, not necessarily for rote what goes in where. So we have one side length. I'll say A equals 7, but we don't have the other side length. So that is our unknown. And we do have the angle, which is 25. So we have two side lengths, or we're talking about really two side lengths and the angle in between them. In order to talk about the area, we know that the area is equal to 29.6 centimeters squared. So now we can take all these pieces. We have one unknown and a bunch of ingredients to plug into this formula. For A, I plug in the area. 29.6 equals 1/2 times 7 times x times sine of 25. So you have an unknown. If you have a TI Nspire, you can go ahead and plug this into your numerical solve. If you do not have a TI Nspire, you can go ahead and multiply both sides by 2, divide by 7, divide by sine, and start moving it all around. Go ahead and tell me what your answer is. You should get that AB is equal to, it's like 20.0 something, 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 something. Since it doesn't tell me how to round, I'm going to round to 3 significant figures, which actually ends up being 20.0. So notice you went in, that was a significant figure, that was a significant figure, that was a significant figure. You looked to the number after it and it told you to round down. So then it just stays at 0. And that is your final answer. All right. We want to find the area of a parallelogram. They've told us to label it A, B, C, D, and then it starts giving us lengths. So first I'm going to draw a parallelogram. A parallelogram, it's in the name. A parallelogram is a quadrilateral where opposite sides are parallel. So I go ahead and draw in something that looks like a parallelogram. I'm going to go ahead and label the angles A, B, C, D. Again, it does not have to be drawn to scale because as I go through, BC is 7.4, AB is 12.3, and it says that angle A is 39 degrees. None of that looks according to scale, but that is okay because you get the idea here is that we're talking about two side lengths and an angle in between. But now we want to find the area of a parallelogram, which is just split in half a triangle. So if we find the area of one triangle, then we can find the area of the whole parallelogram by multiplying it by 2. So now I've got a few ideas going. I should write some of my plan down. I know that I need to find the area of the triangle. The area of the triangle is 1/2 AB sine of C. Then I know I can find the area of the parallelogram. That's my attempt of making a teeny tiny parallelogram. And I know that that's just 2 times the area of my triangle. So I've got my to-do list here. First find the area of the triangle, then I can find the area of the parallelogram. I'm going to go in and put in what information I have. A, I'm going to say is 12.3, although you could have done 7.4. And then we're going to do sine of 39. Go ahead and tell me what that is. This guy is going to be 28.64 about. I rounded it here just to put it on my page, but remember you're going to be using your exact values for the final answer. Once we take this final answer, realize that we are not done yet. Refer back to your to-do list. We need to find the area of a parallelogram. So we're going to take this guy and we're going to multiply it by 2. Go ahead and tell me what that is. You should have gotten 57.3. We'll put centimeters squared, and that is the end of our problem. All right. The roof is in a shape of an isosceles triangle, PRQ, where PQ equals RQ. So I'm going to go ahead and draw in an isosceles triangle. Remember that an isosceles triangle is a triangle where 2 side lengths are equal, or 2 angles, and 2 angles are equal. It says that PQ is equal to RQ. So those guys are equal. It says that angle P is 61 degrees and that PR is 12 centimeters. And we want to find the area of this triangle. So I'm going to start writing down a few things that I know. I know the formula for the area of a triangle. So I'm going to write that down. I can then use this as a spot to say, okay, well, what do I need to do in order to get to that? I have an angle. and I have a side length, but I'm missing another side length. So I need to find one of these. It's a non-right triangle, so in order to solve for missing parts of non-right triangles, we only have two options here, law of sines or law of cosines. That's it. So looking at what we do have here, we know that this is an isosceles triangle. So if we know this angle, we know that the other angle over here is also going to be 61. Using that, we can then solve for our third angle. I'm going to take 180 minus 61 minus 61, which is going to be 58. Now I have all of the angles and one of the side lengths, and I need to solve for the other side length in order to find this guy. So I have that A is equal to 12, B is equal to question mark, which is X, and then the angle in between those two side lengths is 61. So I'll have C equal to 61. You could choose to do this side length, which will end up being the same, and then using both of these as A and B, and then solve with sine of 58. You could have used these and used sine of 61. As long as you just change that relationship of two side lengths and the angle in between, it should all work out to get you the exact same number. So first step, I need to solve for B. I have all of the angles and one side length. You can either try to set it up or remember that when you have angles and you're trying to solve for side lengths, you probably want to use law of sines. But remember that you can just set it up one way or the other and then figure out which way will get you only one variable. Because there will be one way that will have multiple variables and you don't want that. You just want one variable. So how to solve for x is that I'm going to do sine of 61 over x equals sine of 58 over 12. Go ahead and tell me what that is. You should get that x is equal to something along the lines of 12.376. When you're writing it down on your paper and it's not your final answer, you can round it to whatever you want it to be. It's a place for you to mark on your page that this is the number that you got here. So then that way when you use your exact value in your calculator, you can scroll up and find that number and bring it down. This is just for you to keep track of the information. It's not the final answer, so how you round it, it doesn't matter here. Now that we have this information, you can find the area. We're going to multiply it by that 12.376 guy, and then we're going to multiply it by 12, and then we're going to multiply it by sine of 61. Go ahead and tell me what that is. The area ends up being 64.9 centimeters squared.